go. Carrying on in the what radicals unit. Okay, and so today's lesson is adding and subtracting, combining, okay, radicals. Here we go. So, you guys, I want you to write this down. Background knowledge as per usual, okay? Making the connections in the brain cells, okay? Connections. Back to what, combining like terms in, first week of school, okay? So, let's write this in our notes just for fun. Okay, 2x squared minus 3, x squared, okay? Just write that down, okay? And when we say combining like terms, are those like terms? Yes, right? Because they have the same variable raised to the same exponent, so we can combine them. We can do what it says in front of the 3, okay? So that would be 2 minus 3, is it? And then our result would be negative x squared, and we're done. If this said, this is a quick review, mind you, okay? If this said negative 3x to the third, we would not be able to combine them, add or subtract them, okay? So in order for them to be combined, they have to look exactly the same, okay? Now, you guys, it is exactly the same case, okay, with radicals. When you are adding, subtracting, or basically combining radicals, the radicals have to be exactly the same, or you cannot add or subtract them, okay? There we go. So everyone put equals. You already wrote this down. So all you have to do, are these exactly the same radical? Yes, they are. So you're going to bring over radical 11, right? And then all you have to do is do what's in front of it. So 6 plus 9 is what? 15. Guess what, you guys? We're done. The reason why we're done, okay, is because that is as simplified as you can get. Okay? So, any questions? So that's the moral of the story for today, Pokeroonies, okay? Is that you have to make sure they look exactly the same. So here's our next example. Do these look exactly the same? Yes! Okay? So we're going to bring that radical 3 over, and then all you have to do is what is in front of it. Well, even though it's not there, you know there's a 1 there. So 1 minus 5 is what? Negative 4. And you're done. Yes, 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 it is that easy. Now, we get into a different story when they do not identically match. That is when we get into a different story, okay? And we have to take different steps. Here we go. So here you are. Can we see that? Let me move it. Let me move it up a little bit. Woo. There it is. Okay, so let's write this down. What is the simplified form of 5 radical 3 minus radical 12? Okay, so here this is why, okay, you guys, the original lesson of simplifying radicals was so important, okay? Because you will have, if they are not identical, okay? If these are not identical, which they're not, you cannot combine them or subtract them. And even though it's not there, you know there's a 1 there, okay? This is a radical 3, this is a radical 12. They are not identical, so you cannot add or subtract or combine them. So this one, 5 radical 3, is as simplified as you can get. So nothing to do here. Okay, so let's bring that down. I'll bring it down to here. 5 radical 3, okay? However, and bring the subtraction. Okay, however, we can simplify the radical 12 Okay, so draw the roof. What times what? There's that question again. What times what gives me radical 12, but one of those numbers has to be a perfect square? 4 times 3. Circle the 4. Draw the arrow to signify that you're pulling out the square root of that perfect square, okay? Which is 2. Okay, and what is still left over? Radical 3. So now, do they look identical? Yes, they do. So can we now combine them? Yes, we can. So how do we do that? Bring over the radical 3 and then just do what it says in front of it. A positive 5 and a negative 2 combined would give you a positive 3, and you're done. Okay? So you're going to get examples where both of them will have to be simplified in order to make it happen. Not just one of them. Okay? But when you simplify the first one, if it needs to be simplified, whatever it says under that radical is going to give you the foreshadowing or the clue or the hint or what have you of what the other one should be so that you can combine and simplify. Okay? I don't know. We can do, let me see. Okay, so here's an example of B here. I'm going to bring this over, and we're going to do this together, because this is an example of where you'll have to simplify both of them to get the job done, okay? Not just one of them. There you go. Write that down. 5 radical 32, okay, minus 4 radical 18. Now, your clue that you have to simplify is what, folk Roonies? They do not match. Okay? In order to combine, add, or subtract, they have to be identical. Just like our variables need to be exactly identical to be like terms. Okay? So, we're going to have to simplify this. Then we're going to have to simplify this. Then we can combine. That's all what today's lesson is about. Okay? So, bring down the 5. And radical 32. Okay, so 5 times, right? And draw the roof. What times what gives me 32? And one of those numbers has to be a perfect square. Huh?
4 and 8.
4 times 8. Okay, let's go with that. Okay, because this is a typical. You are correct. Okay, you are correct. However, there is a higher perfect square that you could use, but that's okay if you did this, right? Circle it, pull out the 4, and you have 2, and then you have radical 8. But is this as simplified as we can get? No, there is another perfect square in there. What times what gives me 8? But one of those numbers has to be a perfect square. 4 times 2. Okay, so then we would have to simplify that and do 4 times 2 and pull out that 4 again. So to avoid all of these steps, right, if we just chose the higher perfect square, what times what gives me 32?
16.
Okay, so 16 times 2 would make it only one step to get there. What's the square root of 16? 4. And what's left over? 2. So what's 5 times 4? 20. So 20 radical 2. I hope you can see this in the video. You know what? Let's make sure you can see it in the video. Hold on. Okay. Here we go. Okay, so 20 radical 2. So here we are. So a little foreshadowing, you guys. Okay? One step to get there, okay, because we chose the higher perfect square. Now let's bring over, here's our negative 4, and then we have to draw the roof. What times what gives me 18? This is kind of your clue as to what the next, radical is going to be. So what times what gives me 18, and one of those numbers has to be a perfect square. Right, 9 times 2. Circle the 9. And we pull out the square root of 9, which is 3, and there's a negative 4 here. So negative 4 times we're gonna put 3 there, and what is still under the roof? 2. Okay, so there's our leftover. And do these match? Yes, they do. Okay, and so a -4 times 3 gives me what? -12. Do they match now? Yes, they do. Can we add or subtract or combine them? Yes, we can. So you're going to bring over that radical 2 and then just do what it says in front of the radicals. Positive 20 and a -12 combined gives you 8 radical 2. And that's it. That's adding and subtracting radicals and, simplifying first if you need to make sure that what? The 2 radicals match. Okay?